Welcome to this explainer. You know that patch of peeling paint or that powdery white stuff you sometimes see near the floorboards? If you're looking at that and thinking it's just an ugly little cosmetic nuisance, let me stop you right there. As a specialist waterproofing consultant, I can tell you we are actually looking at a massive structural threat. Today, we're unpacking the science of foundation failure caused by rising dampness. It's this crazy, invisible force that literally defies gravity to destroy buildings from the inside out. Let's get into it.
Here is our roadmap for today. Number 1, the science of dampness. 2, why damp proofing fails. 3, new foundations, the gold standard. 4, remediation for existing buildings. And 5, the ultimate pro tip.
All right, starting with section 1, the science of dampness. Let's understand the root of the problem. Take a look at the ugly reality of this failing brickwork. This is exactly what happens when groundwater infiltrates a wall. As moisture gets pulled up from the soil into the masonry, it brings all these dissolved ground salts right along for the ride. Now, when that water eventually evaporates from the surface, it leaves those salts behind. And as they crystallize inside the pores of the brick, they expand. They will literally blow the face off the brick and turn solid mortar into absolute dust. In the industry, we call this a salt attack. But how does the water actually get up there in the first place? Well, it happens through a physical mechanism called capillary action. Think of the microscopic pores in the bricks and mortar acting like millions of tiny little straws. Because of surface tension, these incredibly fine tubes create a suction force that is so strong, it actively pulls moisture out of the soil and upwards. It completely defies the downward pull of gravity. It's pretty wild when you think about it. So this damp just keeps rising up these tiny straws until that upward suction is eventually balanced out by gravity. But here's the kicker. The water it draws up is rarely just pure water. The sources of these destructive salts can be naturally saline groundwater, soil fertilizers, or even leaking sewers. Actually, when we find really high levels of nitrate salts, it's often a dead giveaway of a broken sewer line, or it tells us that a historic building was once used as a stable. Bottom line, the salts are the true destroyers here, eating the masonry from the inside out. Moving on to section 2, why damp proofing fails. How does water manage to bypass our modern defenses? That really is the million-dollar question, isn't it? I mean, since the late 19th century, we've been building houses with damp-proof courses, or DPCs. These are basically impermeable layers like plastic polyethylene or traditional slate built horizontally right into the mortar bed to block the water. So how on earth does water still manage to bypass these physical defenses in modern walls? Well, 9 times out of 10, the answer is a bridged DPC. A bridging failure is exactly what it sounds like. Imagine a fortress protected by a highly effective moat. That's your DPC. Bridging is like someone coming along and just lowering a drawbridge right over that moat. By placing some sort of material higher than the damp-proof course, you're accidentally creating a continuous alternative path for the water to travel along. You've essentially rendered that protective barrier entirely useless. Let's look at the actual everyday culprits that routinely create these bridges. Honestly, more often than not, it's a landscaping error. Someone builds a brand new patio or a raised flower bed right up against the exterior wall. Boom, bridged. Internally, it could be a plasterer taking the wall finish all the way down to the solid floor, right past the DPC line. It can even be something as simple as mortar debris dropped down into a wall cavity during construction or blocked air bricks. Every single one of these acts like a wick, transferring water right past your defenses. So here is a critical engineering rule you absolutely need to remember: 200 millimeters. To remain effective and to avoid rain splashback or accidental bridging, a damp-proof course must be kept roughly 200 millimeters, about 8 inches, above the external ground or paving levels. If your external dirt or concrete is higher than that mark, your barrier is compromised. Simple as that. Okay, section 3, new foundations. Let's talk about the gold standard for protection. When we're talking about new builds, the absolute benchmark is the rigorous British Standard 8102-2022. This standard insists that design teams and waterproofing specialists don't just guess. They have to conduct a strict risk assessment. They must actually assess the water table and agree on a specific head of water pressure, basically calculating exactly how much hydrostatic pressure the below-ground structure is expected to endure. It's all about managing expectations and making sure the engineering matches the environmental reality. Based on that risk assessment, we have to choose very specific materials, and we generally have 2 main players here: On one side, you've got bitumen waterproofing. It's highly durable and super flexible, which makes it absolutely perfect for exteriors and foundations where the building might shift or settle slightly. On the other hand, you have cementitious waterproofing. This stuff is rigid and non-toxic, making it your go-to for the interior side of basements, bathrooms, or even drinking water tanks. But for those deep foundations facing the full wrath of groundwater, bitumen membranes are the ultimate preventative shield, hands down. Whether it's hot, liquid-applied bitumen or prefabricated SPS rolls, this material forms the robust, flexible, continuous layer you absolutely need to protect structural concrete from below-ground moisture ingress.
Moving to Section 4, remediation for existing buildings. What do we do when the building is already built?
So what's our move when we have to treat the patient? Say we've got a heritage property or an older building with an irreparably bridged DPC, and we obviously can't just lift the house up and rebuild the foundation. Well, we execute a highly clinical surgical process called chemical DPC injection, and we do it without tearing the house apart. Step 1, we rigorously survey and diagnose to ensure it's actually rising damp and not just a plumbing leak. Step 2, we drill precise holes, about every 100 to 120 millimeters, straight along the lowest mortar joint. Step 3, we inject a specialized damp-fighting cream. And finally, step 4, we replaster. Let's look a little closer at that injection step, because the chemistry here is brilliant. The fluid we use is typically an alkyl or alkoxysilicone cream. Once you inject it, this fluid diffuses deep throughout the mortar bed. A catalyst inside the fluid triggers a chemical reaction. The solvent evaporates, and it leaves behind a silicone resin that actually bonds to the masonry pores. It creates a completely hydrophobic or water-repelling barrier. It literally physically stops that capillary climb in its tracks. And listen up, because this is absolutely crucial. Chemical injection alone isn't magic. If a contractor just injects the wall and walks away, the job will fail. Why? Because the existing plaster on that wall is already packed with those destructive moisture-attracting salts we talked about earlier. Removing all of the old, salt-laden plaster and replacing it with a salt-resistant, breathable material is a non-negotiable step for the long-term health of that wall. Plus, you've got to improve the subfloor ventilation and take staged moisture readings over time. And that brings us to Section 5, the ultimate pro tip. Check out this water management strategy featuring a proper French drain setup. Let's deconstruct its anatomy for a second. You have your foundation wall, protected by a membrane, sure, but crucially, right down at the base of the footing, there is a perforated pipe encased in a bed of coarse gravel. This system is designed to actively intercept transient groundwater as it percolates down through the soil. It grabs that water and carries it away before it ever has a chance to just sit against your concrete. Because here is the fundamental truth of our industry. Site drainage is the absolute first line of defense against all moisture issues, period. The soil around the building must be graded on a slope to direct surface water away. Downspouts need to discharge far, far away from the foundation. Because frankly, the thickest bitumen membrane and the most expensive chemical injections in the world mean absolutely nothing if water is allowed to permanently pool against your structure. I want to deliver this core philosophy to you with absolute authority. You cannot fight water. You can only redirect it. Managing the water table and utilizing gravity to guide moisture away to a storm sewer or a dry well, that is the ultimate key to structural longevity. Mother Nature always wins a static fight, so you have to give the water somewhere else to go. So I'll leave you with this provocative question. Is your building's first line of defense currently compromised? I challenge you, after this explainer, to go outside and take a look. Check the grading of your soil. Inspect where your downspouts empty out. Look for that crucial 200 millimeter clearance below your damp-proof course. Remember, foundation failure doesn't happen overnight. It happens one microscopic capillary climb at a time. Thanks so much for joining me on this explainer, and keep yearning.